Hi and welcome back. We're going to talk about mass number and isotopes. In the last video, right, we talked about atomic number. And so the atomic number is the number written above the element in a periodic table. And that's the number of protons. And so He is a very funny element. He, right? It is helium. And its atomic number is 2, which means that it has 2 protons inside of its nucleus. And we have to talk about something else. We have to talk about mass number. And whereas atomic number is given the symbol Z, the mass number is given the symbol A. And it is defined as the number of protons plus the number of neutrons. So, for example, if our helium atom had 2 protons and had 1 neutron, then we would say it would have a mass number of 3. If it had 2 protons and 2 neutrons, right, it would have a mass number of 4. And both of these would be considered to be helium. If you've got 2 protons, you are by definition helium. So the number of neutrons can vary though, and so that's why we have to keep track of this via what's called the mass number. Now, these are referred to as isotopes, and so isotopes are when you've got atoms of an element that differ in the number of neutrons. So isotopes differ in the number of neutrons. And since neutrons are neutral, I write a little n with a little 0 above it to remind me that it's neutral. Okay, so how do we name these? So we actually give each one of these names, and so the name of this can be written a couple of different ways. We can write helium-3, or for the bottom isotope, right, we can write helium-4, and so you've probably figured out that this is the mass number that I'm writing right after. And in regular conversation, right, we might talk about helium-3 versus helium-4, and it's just a very easy way to pronounce it. There's another way we can write these symbols as well. We can use what we call the Nuclide symbol, and the Nuclide symbol is kind of a funky name, but for a fairly simple concept actually. And we just write 3 things when we write a Nuclide symbol. We write X, which is just the element symbol. So helium is He, and then A, that is the mass number, and Z is the atomic number. And so we just write it like that when we write the Nuclide symbol. So we could take helium-3 and we could rewrite it using the Nuclide symbol as follows. So we write He for helium, and then the mass number we write up top. So its mass number is 3, and its atomic number we write down the bottom. So that would be 2. And for helium-4, right, we would write He for helium. We'd write a 4 up top. The mass number goes high, and the atomic number goes low. So those are the 2 different ways we can write out our helium atom's symbols. We could go ahead and work a kind of a backwards problem here. Imagine we've got an atom of carbon-14, and we want to know how many protons and how many neutrons it contains. So how might we try something like this? Well, the first thing we've got to do is find it on the periodic table. Carbon is just C. Ca, remember, is calcium. And directly above it is that magic number there, that atomic number that is so important. So that is Z. And the number of protons, of course, is Z. So we can just go ahead and say that there are 6 protons right away. Now, the 14 in carbon, that is the mass number. And the mass number, if you remember, is the number of protons plus the number of neutrons. So at this point here, right, we've got 14 is equal to the number of protons, 6, plus the number of neutrons. And so the number of neutrons then is just the difference between 14 and 6, which is 8. So sometimes I find it easier to work backwards, and I just think, what would I have to add to 6 to get 14? And 8 is the answer, but I suppose it's a subtraction problem technically. So carbon-14 is a particular isotope of carbon. Carbon-12 is the most common isotope. Carbon-13 is about 1%. Carbon-14 is very, very rare. Only a few atoms in a million are carbon-14, but it has 8 neutrons and 6 protons. Now here's one for you. So how about I give you something like argon-40? So can you go ahead and do a couple of things? Can you write the Nuclide symbol? And can you tell me also the number of protons and the number of neutrons that are contained in here? So just go ahead and pause the video and write the Nuclide symbol for argon-40 and tell me the number of protons and neutrons, and then we'll compare notes together. Okay, I'm back. So let me go ahead and start a new slide here. Okay, so argon-40. So I suppose, right? So let me go ahead and write argon 40 right here. So I need to know what argon is on the periodic table, what symbol it is. It is Ar, and up above there is a number 18. The number down below doesn't matter at this point. So what do I need to know? I need to write the Nuclide symbol, so I write Ar, and up top I write the mass number, and down bottom I write the atomic number. So remember that this is the mass number, the number of protons and neutrons. And the atomic number, right, that's that thing we get off of the periodic table of elements. So that is the 18. So that would be the nuclide symbol. How do we know the number of protons and neutrons? Well, actually, the number of protons, right, we already have right off the bat. There are 18 protons. But if we know that 40 is the number of protons plus the number of neutrons, and if we know the number of protons is 18, then we just have to solve for that. And you can do this by inspection or by subtraction. You can say, well, 22 and 18 add up to 40. Or if you like, you can say, oops, sorry, I can't spell 40. You can take 40 minus 18, and that's equal to 22 neutrons. So there's 18 protons, and there are 22 neutrons in an atom of argon 40.